Good day, this is Mr. Max. So I'm looking at the binomial expansion. Um, so it's been a while, so we're going to start posting um, again some work, especially with regard to the AS levels. Okay, so let us just take any two terms and let's say we say it's A plus B. Let's say we raise them to the power of 1. Okay, so or let's even start off with the power of 0. Now, as long as a plus b is not equal to 0, okay, or as long as this whole thing in the bracket is not 0, then you should know that anything inside or anything raised to the power of 0 is equal to 1. Okay, so let's take a plus b raised to the power of 1. Well, looking at the answer here, you're just going to have a plus b. Okay, but what if I was deciding not to use the letters a? What if I was using x plus y or so? Then I'll still have x plus y. That's the same if I was to use p plus q. Then I'll still have p plus q. So what I'm really interested in is to make this pivot where we can say, let us look at the coefficients of these various terms. And what you realize is then the coefficient here will be 1. And let's say we write them like so. Okay, so let me just remove then, because basically these things are all the same, irrespective of which letters we use, but we're going to stick with a plus b. So let's go ahead and expand a plus b raised to the power of 2. So basically this is the same as a plus b multiplied by a plus b. And once we do that, you're going to have a squared plus ab plus ab plus b squared. Then let's clean this up further. It's a squared plus 2ab's plus b squared. Again, when you look at the coefficients here, you realize there's a coefficient here of 1, there's a coefficient here of 2, and there's a coefficient here of 1. So if I have to go ahead, I'll write 1, 2, and 1. You might see a pattern that is starting to emerge here. It appears as if that once you add these two together, you get this 2 here. Okay, so is there another pattern? Let's suppose I continue and I put a plus b, this binomial, to that power. Well, we know that this is a plus b all squared times a plus b. From our previous work, we know what the a plus b square is, and that is nothing but a square plus 2ab plus b squared. And we're going to have to multiply that out by a plus b. Okay, looks like a long process, but let's continue and see what it gives us. So if you have to multiply, you get a cubed plus a square b plus a, now you have to look, it's a cubed plus a square b. Now we start with the second one, so it's going to be 2a, just use a different color just so you can see. So basically what I have is I'm multiplying this 2, that's where I get this a cubed. Then I multiply that a with the b, that's why I have a square b. Now I'm taking the second part, of which I am multiplying the 2ab times that one over there, and I will take the same thing when I do that one over there. So let's just do that quickly. So 2ab times a, that is 2a squared b. Then 2ab times b, that's going to give you 2ab squared. Okay, and let's take the last term that is there. That is namely this b squared term over here. So we're going to say b squared, we're going to multiply it with the a and multiply it with the b, and then we see if there are like terms that can be collected. So b squared times that is going to be ab squared, and b squared times b squared, that's simply going to give you b cubed. So let's go ahead and clean this up. So a cubed stays a cubed, a squared b plus 2a square b, that gives us 3a square b. Then 2ab squared plus ab squared, again that gives us 3ab squared, followed by b cubed. All right, so we can just highlight the coefficients, right? There's a coefficient of 1 here, there's a coefficient of 3, there's a coefficient of 3, and there's a coefficient of 1 over here. Okay, so maybe I should go ahead and just put those coefficients where I have indicated, so you can just perhaps follow. All right, and then you see the general pattern that emerges. Right, so if I was to go back and I write it in here, I'll have my 1 over here for the coefficient. I have a 3, I have another 3, and then I have a 1. So looking at this pattern here, you would see that it then indicates that to get 1 plus 2 gives you this 3 over here, and 2 plus 1 gives you this 3 over here. And so we can continue without having to do this long binomial expansion. So if we were to look for a plus b all raised to the power of 4, we can follow a general pattern that is there. So we're going to continue to the special triangle, and we are going to see how we can find those missing values. So again, I'll start off and maybe I'll just get this in blue. So this is going to be 1. 1 plus 3 is going to be 4. 3 plus 3 is going to be 6, and 3 plus 1 is 4, and then flanked by that 1 here. So this is going to be the coefficients of the next one that I'm going to do. Right, so those coefficients 1, 4, 6, 4, 1, and I'm going to follow the general thing. One of the things you should also realize is, let's go back to this one, perhaps so that I can make this point a bit clearer. You should have noticed that this is raised to the power of 3, and the powers of a are decreasing. Can you see that? The powers of a. Let's go to the final one. The powers of a are decreasing. That's cube, that's square, and this is obviously to the power of 1. Okay, and the powers of b, for example, are increasing. Okay, so this is going to be 1 over here. And when you look at, let's also have the 1 over here. So in an actual case, we have that the powers of b would be increasing as we are going along this trajectory. So what we are seeing is, we are seeing that b is here to the power 1, b is here to the power 2, and b cubed. Of course, there is 1 here, but it's just b to the power of 0. So using this logic, I can definitely continue and complete this. So I'm going to have the powers of a, as again, as I said, they are going to go down. So a raised to the power of 4, that's the coefficient is 1. And the next one, the coefficient is 4, according to that triangle that I have there, that pattern. So it's going to be 4. A is going to now increase and b is going to gain 1. The next one, the coefficient is 6, as you can see from the triangle over there. 6a is going to decrease and b gains 2 more. And then the next one is going to be plus 4, the coefficient that you have. 4, a is going to lose 1 and b is going to gain 3. And then the last one is just 1, the coefficient, there's no need for us to write it, but it will just now be b raised to the power of 4. Then also, just so that you can see something as well, you should realize something, that there is a pattern also that one should be able to see. You see that this power that is here, let's call it our n. If you add the terms, you see that they must add up to that 4 over there. 2 plus 2 gives you the 4, and 1 plus 3 gives you the 4, and that last one is 4. And so you can go ahead and you can continue as we go. And let's suppose we start with n. So there must be a way to do this, but it becomes a little bit tricky the moment we decide, okay, let's make this maybe power 10. And then we have to go back to our triangle, and then we have to got all those coefficients, and it becomes a tedious and a very long process. So we need then to come up with a different pattern. So Pascal's triangle, which is what that triangle is called, by the way, it works, but it can be a bit tedious whenever we have very high powers there. So this guy, or this is known as Pascal's triangle. Right, so when you get a general question, they ask you to write down the first three terms. Well, you can find it by using Pascal's triangle. Of course, if you have that time to waste. So what is it that we know? So looking and working from that pattern, so this is going to be a raised to the power of n, okay? And I'm going to leave a little bit of space here for the coefficients. And then we know the next one obviously is going to be b to the power of 0, okay? But here's the thing that you must now realize is that n will be decreasing, or the a will be decreasing. So the next one will be a to the power n minus 1, because like for example, if it was 4, it becomes 3, so it's decreasing. And our b is gaining. And then we continue, the next one will be a raised to the power of n minus 2, it's decreasing, and b is gaining. And this continues until we arrive at a scenario, and maybe I should be explaining what we have here. We arrive at a scenario where we're going to have that last term as b to the power of n. So we're going to have the last term as b to the power of n, and a will be to the power of 0. That is what we're going to get. However, there's one particular problem, and these are these coefficients that we could generate from Pascal's triangle. So we could detect from the triangle of Pascal what these coefficients are. But now we can't see those coefficients in the statement, so the statement is therefore a bit incomplete. So what we can then look at is we have to come up with a general way in order for us to find the coefficients that are supposed to be in front here, looking at our general pattern. Okay, and the way we look at that is we're going to introduce something a little bit more. And that is what we refer to as, maybe I should just explain the concept of factorials to you, because this brings us to a very interesting concept. We are not going to have the time and day to do Pascal's triangle and to use Pascal's triangle all the time. So we come up with a formula which is n choose r, and that is equal to n factorial over, well, that is r factorial, and I have n minus r factorial. It might be written slightly different, but it is what you get. Now, what does that mean? So let us just look at bringing down the, maybe the one of a plus b raised to the power of 4, the one that we have over there, say. So I'm just going to rewrite it nicely so that we can have it, so you can just follow where I'm going with this. So we know that from a plus b raised to the power of 4, we had 1a to the power of 4 plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus, well, you can call it 1b to the power of 4. So we're now going to look at a way for us to find these coefficients, okay? Because you could see the other particular format there. Now, what we do there is we bring in this concept where we say n being our n that is over there. So, for example, in this particular one, we're going to say n choose 0, okay? maybe before we can look at that and explain that a little bit, let's just bring in a few things that we need to understand whenever you calculate that. What does 5 factorial mean? For example, if someone say 5 factorial. So basically this is 5 times 4 times 3 times 2 times 1, which is basically a combination of doing things and permutations, right? So what we have, if you have, for example, 5 factorial, let's say divided by 2 factorial. Well, of course, this is nothing but the same way that I did it over there. Then you multiply with 2 times 1. And it is very easy to calculate this type of scenario where you can now say, okay, wait a minute, if you are dividing by multiplying by the same thing, you can actually take out the common factor. So at the end of the day, we have got 5 times 4 times 3, and that is 20 times 3, and this answer is 60. So we do have a button on the calculator for the factorial, and you can find it on the calculator. So I'll pull up my calculator, and you'll see that on the calculator, it will be um, something with an exclamation mark, like here. So if I was to say 5, and I shift to activate that one, 5 factorial, it will give me 120. And surely you'll get 120 if you were to multiply that out. So let's go back and see if I say 5 factorial, the one that I did over there, and it divided by 2 factorial. 5 factorial divided by 2 factorial. Well, surely I get 60, as you could see what my working was over there. But in order for us to continue, we need to bring in a little bit more. We need to understand what certain things are. Let's suppose we bring in something like 0 factorial. What does that mean? Okay, it has to mean something as we go along, because this is going to be very all good for us to be doing something, so we have to come up with a special definition. So we also have to look at different scenarios. So let me then start by bringing in that formula that you are supposed to know, and that is the general formula that comes from the general term. Right. So we are now trying to identify using this in order for us to find those coefficients that I've highlighted there. And I'll come back and explain more on the examples. So the way we write it is you can either decide to write it as a vector in a vector form, so to speak, where you can say, let's say, n choose 0, okay, and n choose 0 means if you have to the n that I have over here, so if we have a plus b raised to the power of n, the n is the index, so when I'm using this one here, our n is going to be 4. So if I now replace that with 4 using the formula I have over there, it's 4 factorial over, now my r is 0 factorial, and then the difference 4 minus 0 factorial. Okay, so that gives me 4 factorial over, again, 0 factorial and 4 factorial. There's no need to put brackets there, but I think you do get the idea. Now we need to come up with what this is. All right, so if you were to grab on what we said is, we realize that this is the same as 4 times 3 times 2 times 1. But we are counting down, so we have to say times 0. Okay, but the moment you say times 0, it indicates that everything on top there will just be 0. So if I now have to end there, we have to give this 0 here a sort of explanation or a definition. Okay, So there has to be something in order for us to be able to solve that. And that is where it comes that that 0 factorial is equal to 1. Otherwise, it will not work because you're seeing that we are counting downwards as we are going. So in this particular case, you can also apply a little bit of what you know. That goes in itself once, that goes there once. So at the end of the day, you have got a scenario where you have 1 over 0 factorial by 1. So I just indicated that 0 factorial is equal to 1. So eventually you have a scenario where you have 1 over 1. So what does it mean? It means that for any, and you can see that this answer that we have here is equal to 1, which is the coefficient that we have over there. So if I was to give you 5, choose 0, or sometimes it's written like this, 5, choose 0, okay, in that notation, this answer will always be 1. Because from Pascal's triangle, we've realized that we have got 1 over there. Okay, so let's see if we can go to the second one where we now say, okay, 4, choose 1, in order for us to see if we're going to get the same 4, choose 1, not 2, 4, choose 1. So that is going to be like so. And using that, it's 4 factorial over, okay, my r factorial, which is 1 factorial, then 4 minus 1 factorial. This gives me 4 factorial all over, of course, 1 factorial, and this is times 3 factorial. Now, I can go ahead using the information that I use, counting downwards. It means 4 times 3 factorial. I don't have to go down until 0 factorial. So 1 is also just 1, so that is 1 times 3 factorial. Good. Looking at my 3 factorials over there, I should be able to cancel them out. And this final answer is 4 over 1, which is equal to 4. And all is all good now. You can see that the coefficient there is 4. Will it work for the third term? So let's see. If we decide to take 4, choose 2. So 4, choose 2. 4, choose 2. Using that, it's 4 factorial over 2 factorial multiplied by 4 minus 2 factorial. Good, right? So remember, we need to find a 6 there. And then this gives us nothing but 4 times 3 times 2 factorial, and this is where I'm going to end, over 2 factorial times 2 factorial, if you say 4 minus 2. Okay, so I can actually also get rid of the brackets over there. So this is nothing but 2 factorial. Of course, you can go ahead and start canceling out this 2 factorial and this 2 factorial. So basically, I have got 4 times 3 over 2 factorial, and 2 factorial is nothing but 2 times 1, and that is 12, and half of 12 is 6. And surely that is the coefficient that I have for that term. And you realize that the coefficient there is 6. And so I have found a new way to find those coefficients without me having to use Pascal's triangle. So I have to complete my formula over here. So here is going to be n choose 0. Okay, which we can go ahead and write like so. Just maybe clear this up a bit so that it's, so here we have n choose 0. Here we'll have n choose 1. We'll just write it like this, like a vector way. And here we'll have it as n choose 2. So this one here is n choose 2. And so we go until we get to n choose n. Now a scenario where the last one becomes n choose n, you will also have to define it, because as I go on, you're going to have a 3, a 2, a 3, a 4, until you get to what exactly is the same. So if it was a 4, it will now become like 4 upon 4. So 4 choose 4. So here will be n choose n, for example. So we now need to define just quickly before we can go and see what do we know. So we know the following. We know that 0 factorial is equal to 1. Okay. We know that if I have something like 4 choose 0, okay, it's also giving me 1. And we can use that from our work that we did before for that coefficient. So I'm going to remove the 4 and I'm just going to replace it with an n so that you can follow. So this is going to be n choose 0 is equal to 1. What is it that we also need to know? What will this scenario be? Okay, like if I have 4 choose 4, for example. Now remember, it's 4 factorial over 4 factorial and then 4 minus 4 factorial using our formula up there. So that's 4 factorial over 4 factorial times 0 factorial. Now remember, I said 0 factorial is 1, and so basically this whole answer is 1. So this is also 1. Okay, very important that we know that and we work from there. So we can actually identify or find the coefficients of the terms using this over here. We can find the coefficient of that, we can find the coefficient of that, and so on. So this brings us to a pattern, and we can actually complete that pattern. And I'm going to bring in what we refer to as the binomial theorem, because this is all good and well, but there is also a way to find that. All right, so let's just bring down this other formula again, or this expansion of a plus b raised to the power 4, where we had no need to write the a, by the way. So the first, this was a to the power 4 plus, you can still remember, our coefficient became 4 and then 6 and 4, so our coefficient was 4, and then a decreases, b gains, then 6, a loses more, b gains 2 more, and then plus 4 because it's symmetrical, 4, a 1, and then b cubed, and the last one was b to the power of 4. Very important. The reason why I'm rewriting this is I want to explain a certain scenario. Do you realize that this is the first term, and this is the second term, and this is the third term, and this is the fourth term? So if I was to ask you to find the fourth term, what would be the fourth term, for example? You would be saying, okay, that means 4 choose. I hope you can see that from our work here, my r, okay, because remember this is the fourth term is 4ab cubed, 4ab cubed, but going back to my formula here, so that's the first term, term 1, term 2, term 3. Can you see that you have got one less than that, and term 4 will be where you have the r value here will be 3. So if I'm asking for the fourth term, my r will be 1 less. So it means I'll now deal with 4 choose 3, for example. And let's see, let's put that in practice. So that's 4 factorial over 3 factorial times 4 minus 3 factorial. Okay, so 4 factorial over 3 factorial times 1 factorial. Okay, and obviously this is 4 times 3 factorial over 3 factorial times 1, because that's what 1 factorial means. Well, of course, you can actually go ahead and you can sort of cancel out the 3 factorial, and you realize this answer is only equal to 4. And surely you can see my coefficient here is exactly correct. So I actually count or use that to find the coefficient for the fourth term. All right. So, but what if I ask you what is the fourth term? And this is where this formula will come in handy. So we have to get used to using this notation, because we're going to use this notation to do questions where we do a little bit of more advanced questions for this course. Right, so the general theorem allows us, because you could see that a sort of decreases by whatever R is, and B gains as we are going. So that brings us to the general term. So if I was to ask you what is the fifth term would be, if you now had to look at it, you will say R plus 1 equals to 5. You will need to know what is your R, and your R will be 4. It's always one less than that. Okay, so if you want the fifth term, your value of R will be one less than that particular term. Okay, right. So A and B is nothing but our A plus B raised to the power of n that we have when we are dealing with those general binomials, or when we have to expand it. Let's bring in a practical example. Let's say we have to, and I'm looking for a question that we perhaps can use this formula that I have now introduced you to. So what if we have A plus B? So let's say we have A plus, let's say 2B, just to spice it up a bit. And let's say we go all the way, let's say to the power of 8. And let's say we want the first 4 terms. So if I was to ask you what are the first 4 terms, then you would say, okay, wait a minute. The first term is going to be, now remember, what is my value of R? R plus 1 equals to the first term, so R will be 0. So it will be 8, choose 0, that's the first term, and this is my A is A, okay, and it's 8 minus 0, according to our general formula there that we have, okay, according to our general formula, subtracting those two, and then our B, which is this whole 2B here, so I'll have 2B raised to the power of 0. This one corresponds basically with that one. Now, this first term is nothing but A choose 0 is nothing but, remember, I said there are certain things that you need to know when we are dealing with this type of things. N choose 0, any number choose 0 is basically equal to 1. And so this is nothing but 1. A raised to the power of 8, and this is also 1. So our first term is just A raised to the power of 8. This will be the first term. What is our second term? Our second term would be A choose 1. And again, my A value, according to that formula, the A plus B or raised to the power of n, this whole thing here represents A, like so. And this whole 2B here represents this B. So just substitute in. So A, and then I have got my 2B in brackets, and 2B corresponds with this one, and this one is always 1 less than that. So if I choose A, choose 1, remember when you have a scenario where you say 8, and you can see I use my calculator as well, I can use a calculator and use this NCR button, and you realize the answer is just 8. Okay, so 8, and then you have A raised to the power of 7 times 2B, but we are not done because 2 times 8 is 16, A to the 7B. So that would be the second term, and that would be the first term. If you were now to be asked to write down, let's say, the first 4 or first 2 terms and so on. So just to go on and you'll use that. So I know it seems a bit tedious, but it is something worth looking into. Let me bring in 1 or 2 more other um, questions just to maybe make it a little bit more uh, spicy. Let's just bring in add an extra page. Let's suppose you were asked to find let's say I have A plus 2x plus 3. So let's say we take 2x plus 3, and this is all raised to the power of 5. Okay, and they ask us here, expand the following using the binomial theorem. Of course, it's quite some work to do that, but let's say we write down what will be the first term, the second term, and so on, without using Pascal's triangle. Okay, so what is my general formula? It is general term is going to be nothing but n choose r, where a is going to be n minus r and b is r. So this always corresponds. So okay, completing it. So my a is nothing but a 2x and my b is 3. Okay, so this is n, which is 5, choose 0, and my a again, as I said, the whole a is 2x, all right, and that is 5 minus 0, and our b is 3, and 3 should be to the power of 0. Okay, so this again, 5 choose 0 is nothing but 1 times 2 raised to the power 5, x raised to the power 5, and times 1 again. Well, you can just go ahead and say this is nothing but 32 x raised to the power 5 if you were to continue. Okay, what is the next one? 5 choose 1. Okay, then my a is 2x. Now it is 5 minus 1, and this 3 is going to gain 1. Okay, all right, so we're not just going to do most of this. Again, what is 5 choose 1, right? We know from the previous work that I was just explaining that if you have a scenario like that, 4 choose 1, you realize the answer is 4. So 5 choose 1, the answer is nothing but 5 over there. And then 2 raised to the power of 4, 2 raised to the power of 4, x raised to the power of 4 times 3. Okay, you can just go ahead and clean it up. Just 16 times 5. All right, so 16 times 5 times 3 becomes 16 times 5 is 80. 80 times 3 is 240. Then it's x to the power 4. And then if we go for the next one, 5 choose 2. Okay, and then this is my a value, which is 2x, is now going to be 5 minus 2, 5 minus 2, and the b value, which is 3, is now going to get that 2 over there. So again, 5 choose 2. You can use your calculator if you want to do that. You say 5 shift choose 2. Well, that gives you 10. So that is 10 times, well, it's 2 raised to the power of 3 x cubed, and multiply that by 9. The 9 comes from 3 squared over here. So you have got 10 times 8, 80 times 9 is 720. So that is 720 x cubed. And let's continue and get the next one. That is 5 choose 3. So all of these terms are going to be positive anyway. So 5 choose 3 is going to be 2x over here. Then it's 5 minus 3 followed by 3 raised to that power. It's becoming a little bit horrible. But anyway, let's just continue. 5 choose 3. We can just go ahead and put my 3 over there. Again, that's 10 because these things are symmetrical, from the left and from the right when we're doing Pascal's triangle. So what I mean is if you have such a thing, you see that you have 1, you have got a 4, you have got a 6. Guess what you have? Going to have a 4 again, and then followed by a 1. Okay, like the 6 is in the middle. Okay, you would have seen that, right? You have a 1, a 3, a 3, a 1. So it's symmetrical, right? As they approach from either ends. Okay, so anyway, that's 10, and this is going to be times 2 raised to the power of 2, all right, times 3 cubed times x squared. And we can just go ahead and clean it up. So this is 4 times 27, okay, or 27 times 10. Well, it becomes a little bit tough. 27 times 10 times 4, x squared. Okay, that's 270 times 4x squared. Now 270 times 4, that is 500. It becomes a horrible thing. Let's just use the calculator, okay? So it's 270 times 4. Well, 1080 x squared. As you can see, we have descending, okay? 32x to the 5, 240x to the power 4. Okay, so let's choose 5, choose 4. Okay, so when we go 5, choose 4, one dot coefficient, my 2x will be 5 minus 4. My b value, which is 3, is going to get the 4 over there. So if I have to continue with this one, 5 choose 4, you realize that 5 choose 4 is going to be well, let's just put it up there. So we say 5 choose 4. Okay, that is nothing but 5. So it's 5 times 2 times 3 raised to the power 4, and that is x over there. Of course, you can go ahead and clean this up. So this is nothing but 10. 10 times 81x. So this is nothing but 810x. Okay, so what is going to be the last one? Because it's finite, it's ending. 5 choose 5. Remember, this has to be 1. Then 2x is nothing but 5 minus 5. And then my b value, which is 3, gets that 5 over there. Okay, so again, 5 choose 5, like we said before. If you have some scenario like that, 5 choose 5 is equal to 1. Okay, so you've got 1 times 2 raised to the power of 0 times 3 raised to the power of 5 times x raised to the power of 0. Of course, everything here is just 3 to the power of 5. X to the power of 0, or 3 to the power of 5 is 243. 243, and x to the power of 0 is nothing but just that constant term. Okay, just make sure that we have the same answer. Good. Anyway, now what are my terms now? I have got 243, 810x, that one over there for the x squared, then the x cubed term is the 720x. The next one is x to the power of 4, and the way it's been written, the whole thing, you are now getting the descending powers of x. So if we had to write them down, now we can go ahead and write them down uh, and give all the positive terms as they are. Okay, so the first one will be nothing but 32x raised to the power of 5. Let's just use a different color. So this is 32x raised to the power of 5, and the next one was x to the power of 4, 240. So this 240x to the power of 4, and the next one was obviously 720x cubed, so it was 720x cubed, and the next one is 1080, 1080x squared, then you have 810x, and the last one is 243. Okay, so there we have all the terms when the question, if the question say expand the following using the binomial theorem. Okay, and you can put them all to practice and so on. I just want to add one more scenario when we are dealing with this, so that let's say we insert another page. Let's insert another page, the blank one for that matter. All right, so well, it's not where I wanted it. Not where I wanted it, but let's say we are going to insert it over here so that it can be on under that one. So we'll insert the page. Just bear with me. Again, it's been a while. All right. So let's suppose this question right from the onset was 2x plus 3 raised to the power of 5. Okay. So it was 2x plus 3 all raised to the power of 5. Say, for example, we are supposed to find 1, 2, 3, the fourth term. What will be the fourth term? In this particular case, we have done our expansion, but we are looking for not just the fourth term. So let's say I'm looking for the coefficient of the fourth term. Okay, and what did we say? Right? If you have r plus 1 equals to 4, and our r is 1 less than that, our r is equal to 3. So I'm going to start off and say 5 choose 3. Okay, 5 being our n over there. And what is our a? Our a is 2 raised to the power of x. It should always be the difference here. 5 minus 3. And what is our b? Our b is 3. And 3 should always get this 3 that is over there. So let's put it all to practice. 5 choose 3. So when you go ahead and say 5, choose 3, well, that gives me 10. So I have 10 here, and that is 2 raised to the power of 2 times 3 cubed times x squared. Okay, right, so we can go ahead and we can just multiply that out to see what we get. So that's 10 times 2 squared times 27, or 3 cubed. Well, let's just go back. 3 cubed. Right, do you see that I get 1080? Okay, so it's 1080 x squared. Well, of course, that is that term. So if I was to ask you what is the fourth term, that's what you will be doing. But if I ask you what is the coefficient, and then you answer in the exam, you will be say the coefficient of x squared is 1080, if that is what the question demands of you. Okay, using that. So you gotta kind of get used to asking the questions, especially when they do ask you a few things. All right. There's also another way that they can ask you this. They can ask you. You can be given something, and I'm just looking for an example. Okay, so let's say bring in another example. So I give you the expansion of let's call this example, I don't know, for some reason, let's say example da, 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 da. Let's say example where we at now. I'm trying. Okay, so let's say we bring in another example. So let's bring in x plus 2 over x squared, or raised to the power of 7. And the question asking, find the coefficient of x, okay, in that expansion. Okay, well, it's interesting. So the coefficient x, let's bring in another page. If I run out of um, let's just insert a page so we have enough place to work with. All right, again, not where I wanted it. My goodness, just bear with me. It's been a while since I have been doing this type of work. So let's just insert the page again. I think we should be fine right now. Okay, now here's the thing. We don't know here, we don't know what is R. R is unknown to us. Can you see that? What do we know? Coefficient of x, right? We know that this is nothing but x raised to the power of 1. So let's just write down the general formula. So it's going to be 7, choose R, and my A is x, which now be 7 minus R. My B is nothing but 2 over x squared, and it should correspond with R. Now, let me just clean this up a little bit. The 7 choose R, from the work that you have seen me do, that's just a constant, okay? There's nothing there that I want to do or use it for. Let me take this one here. That is 2 raised to the power of R. And then I have got x raised to the power of all this multiplied now, 7 minus R. And then I have something like and you should be familiar, 1 over x squared raised to the power of R. Let's just go ahead and clean it a bit further. So this is 7, choose R. Again, I have no use for this because this is just some constant. And x, 7 minus R. And this is nothing but x negative 2, okay, R. Please be familiar with the laws of indices. Now, if we go and say 7, choose R, okay, and then I have 2R. These are constants that are not really needed for now. And then I have got x raised to 7 minus R, and this is x raised to the power of negative 2R. If you multiply and the bases are the same, so we're going to go ahead and we say, okay, so that is 7, choose R, and 2 to the R, and then you're going to have x. Then obviously you're going to add the indices. So 7, adding those two negatives gives you minus 3R. Now here's the part that is important, because you are looking for the term that the coefficient of x raised to the power of 1. So we need to find, we have to say, okay, x raised to the power 7 minus 3r equals to x raised to the power of 1. That's what we're looking for. So dropping the bases and equating the indices, 7 minus 3r is going to give you 1. Of course, you have negative 3r equals to 1 minus 7, okay, which is negative 6. So you have got negative 3r, which is negative 6, and r is 6 divided by 3. That gives you r to be 2. Now that you know what r is, you are now going to substitute in this formula in order for you to find the coefficient there of x, all right? So let's go ahead and let's substitute it in there. So that is going to be 7, choose 2, 2 is the power of 2, x 7 minus 3 by 2, okay? Again, there was no need for me to use the x because I'm not looking for the value of the coefficient of x. I'm just looking for the coefficient, okay? Find the coefficient of x. Anyway, let's just find what that term is, all right? Then again, we use our calculator, or you can use the factorial formula. So 7, choose 2, okay, that is 21. So this gives me 21 times 4, okay, and of course this is just going to be x, right? If you subtract those things, 7 minus 6, right? So 21 minus, that is 84x, okay? So therefore the coefficient of x is nothing but 84. So that's how you do that one. So you first had to determine what that is. There's kind of way that you can try that, as long as, especially if you have done quite a lot of this, where you don't have to go all that way. But this, for me, is the one that works the best. Okay. Now, when they ask you to find the coefficient or things like the term independent, then you just go ahead here. The term independent is x to the power of 0. That is the term independent of x, because it just simply means it is a constant term. And let me bring in maybe another example that fits that scenario. Okay, since I'm on a roll here, so let's just bring in let's just insert another page and just maybe do one more example, especially that has got such a type of question. All right, so let me look at and see if I can look through my material, if I can find a question where it now talks about a term independent of something. Okay. Oh, okay. Just give me a minute there. Um, let's take this example here. Let's say in the expansion of 2x squared minus 1 over x, see that's the a, that's the b, all raised to the power of 15. I'm working with positive integers there. They ask me question A, must find the sixth term, okay, and then part B, they ask me to find the term which is independent of x. That simply imply that x will be x raised to the power of 0. Again, I'll be using that where I need to find my r there, okay? And then they are saying part C, the term containing x raised to the power of 6. So that whole term, that is what we need to find. Of course, you'll see that it's not that very difficult. Okay, so let's go ahead and find what the sixth term is. All right, so the sixth term, it's r plus 1 equals to 6. So therefore my r will be equal to 6 take away 1. R is equal to 5. So 15, choose 5. That is how we're going to find the sixth term. Our a is this whole 2x squared. So I'm going to put 2x squared, and that will be 15 minus 5. Our b is nothing but 1 over x, and that has to correspond with this 5 over there. So we are halfway done. We can find the sixth term. So it's just a matter of, let's clean this up a bit. Okay, 15, choose 5. So I'll just say 15 choose 5. Okay, that's 3003. So this is here 3003. Then I have 2 raised to the power of 10 because that's 15. Okay, and now you have to be careful because that is going to be x squared. So you have got x squared raised to the power of 10. So that's x to the power of 20. Né? So it's going to be x to the power of 20. Okay, and then this one over here, I'm going to say 1 raised to the power of 5 and x raised to the power of -1 power 5. You should be very familiar with how to rewrite and working with indices. All right. So if you are given something like a 1 over a, you should know that it's a raised to the power of -1. Okay, from your work with indices. Right. Anyway, let's clean this up. Again, as I said, it's a horrible number. This is 3003 times 2 raised to the power of 10 is 1024. Okay, this is just going to be 1 because 1 raised to anything is that, and it's x raised to the power of 20 and times x raised to the power of, this is 20, x raised to the power of -5. Good, let's just get what that value is over there. I think we made a small mistake here. We haven't realized that that is a negative term, so this is negative over here and this is negative over there. So -1 raised to the power of 5 is essentially going to make this constant, whatever it is, that constant will be a negative number. Okay, because -1 raised to the power of 5, if it's odd, it's going to be negative. So let's grab our calculator. It's horrible, but let's see. Okay, I already have the 3003 there. Let's multiply that by 2 raised to the power of 10. Okay, which gives me some millions there. So it's negative. Let's grab our calculator again. 3,075. 3,075. What do we have left? 0.72, and that is x raised to the power, well, of 15, because you have got 20 plus -5 is going to be 15. Right, so that is what we're looking for. The sixth term is that horrible big number over there, where you don't actually need to leave it like that. Could have just left it with 15 choose R or 15 choose 5. Okay, then part B, they ask us to find the term which is independent. Say, so for part B and C, I'm going to use the scenario like I did with these questions over here. Okay, all right. So let me just insert a page so I can continue. Running out of space there. Okay, my goodness. We have to come to this one and then insert the page. Insert the page. Insert the page. Okay, and so all right, so we can continue. So they're saying the term which is independent of that. So what is it that we don't know what is R? Okay, so I'm just going to take a leaf from here, and where I have a 5, I'm just going to replace it with an R. So that part B would be 15 choose R, and then I have got 2 raised to the power of x squared. Then I have got 15 minus R. Okay, and then I have got -1 over x raised to the power of R. So let's just go ahead and get all the constants together. So 15 choose R is going to be a number, and 2 going to be raised to the power of 15 minus R, and -1 will be raised to the power of that. So let's work with our x squared raised to the power of 15 minus R, and 1 over x, remember the x is under. Okay, 1 over x, let me just see before this thing goes flat. 1 over x is nothing but x raised to the power of -1. Okay, there we go. Let's have some power. So that's x raised to the power of -1 R. I'm interested in the x, the ones containing x. Okay, right. So here you have got that 2 that essentially must multiply with that. So we have got 15 choose r, 2 raised to the power of 15 minus r times -1 to the r. Okay, and here's where we are. So x, double of that is 30 minus 2r, and then you have minus r over there when you are now multiplying out this 2. Okay, so let's just clean it up a bit, and we're going to do it here. So it's 15 choose r, you have got 2 is 15 minus r, -1 to the power r, and x, this is going to be 30 minus 3r. Now, when they say, and this is going to be the one that I'm going to use, okay, even to solve for C. So when they say the term which is independent of x, so that is when x raised to the power 0, independent of x, it means the constant term, okay, constant term, x is going to be raised to the power of 0. So therefore, we're going to say x 30 minus 3r is equal to x raised to the power of 0. Right, drop the bases, that is 30 minus 3r is equal to 0. Okay, and then this minus 3r is equal to minus 30. R is equal to 30 divided by 3, which gives you that r is equal to 10. Now that we know what r is, we can actually calculate our p value, because we know r is equal to 10. So we are looking for the term which is independent of x. And I'm going to substitute it. So this is the Holy Grail. And let me just put it perhaps in, let me put it, this is the Holy Grail of my situation. So it's going to be now, let's change the color here. So for part B, so we're going to say 15 choose 10, because r is 10, then it's 2, 15 minus 10, then it's -1 to the 10th power, and of course here I don't even need to work this one out, but I'll just put it down there anyway. So 30 minus 3 times 10. Okay, so this is obviously going to give you x to the power of 0. So I'm not really interested in that, because we say a term which is independent of x, so we're just looking for whatever this whole thing is here is already my answer. -1 is raised to the power of 10 is an even number, so this is going to be positive all right along. So let's grab our calculator and say 15 choose 10. Okay, 15 choose 10, which is 3003, right? Okay, let's just write it down. So it's 3003 times 2 raised to the power of 5, because that is 15 minus 10. Okay, times 1, right? Times 1, no need to write it, but it's just what it is. Okay, I think we can multiply that. 2 raised to the power of 5, that is nothing but 32. So 96,096. All right, so the answer here for B will be 96,096. And that is the term independent of x. You can see it doesn't have an x because it's just a constant term. Right, so when they ask me at part C, the term containing x raised to the power of 6, that means I'm going to use the same scenario here, where I am, let's see, so I'm going to use the same scenario here, but we are just going to change this now to a 6. All right, so we're going to change that to a 6. All right, so let's look at part C. Just add a little bit, another extra page, add a page, insert a page. Okay, so again, as I've said, just bear with me. This is now obviously going to ask me to close and stuff like that. I'll come back. I'll come back. So let's just go back and find our question, binomial expansion. So let's just open it again, and we're going to take off where we left last. Okay, I'm going to just restore. All right. Again, we are looking for part C of this question, the term containing x raised to the power of 6. So part C, let's just change our scenario here. I've got x. In fact, there's no need for me to put the x anymore. Okay, I'll just work with 30 minus 3r and let it equal to 6. So I'm just going to say 30 minus 3r is equal to 6 because they are looking for the term containing x to the power 6. So it's minus 3r is equal to 6 minus 30. 30 minus 6 is 24. So this is negative 24 minus 3r. Then r will be equal to 8. Okay. Negative 34 divided by negative. Okay. So that means I'm going to go back to my holy grail, the one that I have put in parentheses here. Okay, so I'm going to take 15, choose R. So I'm going to say now 15, choose 8. Okay, and obviously where do you go? We go back, and that was 2 raised to the power 15 minus 8. 2 raised to the power of 2 raised to the power of 15 minus 8. Okay, and that was the 2, and then I have negative 1 to the r, negative 1. No need to write it down, but let's write it down. Negative 1 to the power 8. That's my constants. And x, we have got 30 minus 3r. Okay, x is going to be, x will be 30 minus 3 times 8. Okay, let's then see what this generates. This is 15, choose 8. And 15, that is 2 raised to the power 7. This is just going to be 1, and that's x. Now you have got 30 minus 8 times 24. Okay, so 30 minus 24, that is going to be x to the power 6, like what the question is demanding. So this is going to give you nothing but 6. All right, so you already have the answer technically, but if you want to be fancy and you have time, you can actually go ahead and you can calculate it. So let's just go ahead and calculate it. So I'm going to say, okay, 15, choose 8. Okay, that answer, multiply that answer by 2 raised to the power 7. So hard to show, but you can go ahead and you can write it down, and you can see it's a big number, quite large. No need to write it down. You can always leave the answer the way I did, but 823,680. So 823,680 x to the power 6. Okay, but this answer here is perfectly fine as well. All right, so that is the approach that you should have whenever you deal with this type of questions. There's nothing to be afraid of when you're dealing with the binomial theorem. Just know you're given formulas, a formula sheet in the exam, and you can obviously use it. Now, the reason why I did all of this was because I want to get to explain a scenario, and the scenario is gonna come up in the next video. That is when I have this type of expansions. Okay, questions where you are now supposed to calculate the unknown. Okay, the unknown, where we use that binomial series. Okay, like this. So stand by for them. All right, I've got next questions where I will be showing that to you.